I would approach this question, where do the best response functions of each firm come from? Okay. Let's start first with this idea of what is the meaning of best response? What does response mean in this particular setting? In this particular setting of oligopoly, what does response mean?
What one firm should price based on the other firm's price.
Exactly. Response means that it's my strategic variable, which is price, as a function of my competitor's price, right? So the response comes that the Pn, for example, if we're focusing on north side, will be a function. Note this is a function, not a multiplication, of Ps. Okay? So a best response function, because it's a response function, it should be as a function of the other person's strategic variable. In this case, it's price. Where does the best come from? Where does the best come from? Why do we call it best response function? In what sense is it best? What does it do to deserve the name best? Yeah.
It's the best response given a certain given action by the second party.
Yeah, so it's a response given the... But what makes it best? How can we quantify it? Maximizing profit is the answer. What makes it best is the fact that it maximizes profits. Okay? Now, I want you to think about it this way. If I just focus on the profit of the north side, what would the profit of the north side be? Well, it will be Qn times Pn minus marginal cost of the north side. Agree? It's how much you sell at what markup. Okay? But what is Qn? Well, we know that Qn is equal to 8,000 minus 500 Pn plus 100 Ps times Pn, and we know that the marginal cost of north is what? 5, I believe?
Yes.
5. So this is the profit function of north. What is this a function of? What is this a function of? What is the north side's profit a function of?
PS.
PS and Pn, of course. Both of them will matter into the determination of your own profit. So not only will your price matter, but also your opponent's price will matter into your profits. Okay. Now, how do I find, if I treat PS as constant, how do I find the Pn star, or the best response function of firm N, as a function of PS? Well, I'm going to show you two ways. Actually, I'm only going to show you one way, and see if you could figure out yourself the second way. Here's method 1. Method 1. Following from the precessionals. Let's think of a monopoly problem. Monopoly. Remember, in the precessional, one of the problems that we studied off a little bit more than others is the monopoly problem. So imagine that this is quantity, this is price, and you have a linear demand. But it looks like this. Starts with A, it has a slope of B, and this firm has a marginal cost, and let's say that the marginal cost is equal to C. If you are a monopoly facing that linear demand with that constant marginal cost, where is your optimal price? Where do you maximize profit? What price gives you the maximum profit? Anyone remembers the formula for this from your precessionals? A plus C divided by 2. Can we explain that? So practically, if I take the midpoint between A and C, that midpoint is going to give me the optimal price. What do I mean by optimal or best price? I mean the profit maximizing one. And it's going to be A plus C divided by 2. What's the intuition behind it? Well, you can kind of solve it if you want. You can trust me, Or you can go back to your precessional notes. If you go back to your precessional notes, if I do another scale here, and I call this profits, what would be your profits if you sell quantity of 0? 0. What would be your profit if you sell a quantity such that the price is equal to C? 0, because you're selling at your marginal cost. If you're selling at your marginal cost, how much profit are you going to make? 0. So as you lower the price away from A, your profits will increase. And as you increase your price away from C, your profit will also increase. So they'll start with 0. And what you should remember is that this is going to be a symmetric function, so the optimal answer would lie right at the midpoint. So that's where your profits are going to be maximized. Okay? So, if then we go back to the precessional, what's the formula for this demand? It's a linear demand function. This is the intercept A minus, because it's downward sloping, B times Q. This is my function for my inverse demand function. So if I have an inverse demand function and I know the marginal cost and I know the intercept of the demand function, sometimes this is also known as the choke price. Choke price. Why is it known the choke price? Because if you set the price equal to A, you choke your consumer, i.e. they don't buy anything from you. Okay? That's going to be your choke price. So here is how I can use this method 1 following precessionals in order to answer this question. This bit here is my Qn. Agree? This is my demand function, and I'm going to treat PS as constant. Well, this is a bit unsatisfactory for me because I would like to know what the A is. I would like to know what this choke price is. Well, it's not very difficult because all I'll have to do, or what I will have to do in order to get there, is just rearrange the Pn on one side and everything else on the other. Because this function here had P here and quantity on the other side. So let me try and do that rearrangement. So I want to get Pn on only one side, so send this to the other side, this to the other side, so we'll have 500 Pn is equal to 8,000 plus 100 PS minus Qn. All I did is rearranged. So I'm not done yet because I just want to have P on its own. I don't want to have this 500. So I'm going to divide everything by 500. Divide by 500. Divide by 500, divide by 500, and divide by 500. So then, Pn will equal to 80 divided by 5 is 16 plus 1 over 5 PS minus Qn divided by 500. Now, if I study this, PS should be treated as a constant. I don't know what it is, but it's a constant, which means all of this thing here is going to be representing my A. This is going to be representing that choke price, if you like. So if I were to draw the demand function for the north side, or the residual demand function for the north side, it would look like this. This is the quantity for north. This is the price for north. The intercept would be 16 plus 1/5 PS, and the slope would be 1 over 500. Okay, or minus 1 over 500. And I know that the north side has a marginal cost is equal to 6. Once I've done that, I'm almost done. I know this is 6, so I'm really trying to find the optimal price of the north side, which should be here in the midpoint. And that midpoint should be Pn star should equal to a half of 16 plus 1 over 5 PS, which is my A, plus my C, which is 6, divided by 2. Agree? 16 plus 6 is 22. Right? Yes? No?
9 plus is 5, right?
5, yes. Is the marginal cost 5 for North?
Yeah.
Yes, okay. Makes sense. 5. So then I'll have 21 divided by 2 is 10.5. 1/5 times 1 over 2 is 1/10 plus 1/10 times PS. This is going to be the best response function of Pn as a function of PS. Why is it best? Because it maximizes profit. Why is it a response? Because it's a function of your opponent's quantity. So this method here is the easiest, perhaps, and the slightly more intuitive or a bit more formula based, okay? And that's the one that's also provided in your solutions, okay? Here's method 2. Method 2, using calculus. So in method 2, you could, in principle and in practice, take this profit function and say, this is my profit of n. If I want to maximize the profit of n, it must be that the derivative of Pn with respect to the derivative of profit with respect to price must equal to 0. So one little exercise that you could do is to try and differentiate this expression with respect to Pn, holding PS constant or treating PS as if it's constant, setting it equal to 0, rearranging, and see if you find exactly the same answer. Actually, I'm going to give you a few minutes to try and do that yourself. So see if you can write down this profit function, take the derivative with respect to Pn, and see if you get the same answer.